how do we know that momentum is actually conserved? Let's try to find a mathematical proof behind the conservation of momentum. Okay, let's assume there are two objects, object A and object B. And this is actually the scenario before collision. So before collision, we have an object A of mass m1 moving with a velocity of u1 in this direction, as symbolized by this arrow. And we have another object B of mass m2 moving with a velocity u2 in this direction. Now during collision, that is during that short period in time where A meets B, A will exert a force on B. Let's call this force F1. So this is the force that A exerts on B, F1. And at the same time, B will exert the same amount of force back to A. Let's call that force F2. Now from Newton's third law of motion, which states that every action has its equal and opposite reaction, we can deduce that F1 should equal to negative F2. And from Newton's second law of motion, F equals to ma. If this is equation 1 and this is equation 2, let's combine these two equations to see what we can actually get out of this. Okay, so F equals to ma. F equals to m v minus u over t. I'm sure you recall that the rectilinear kinematic motions, there is an equation which states v equals to u plus at. Arranging this equation and making a the title will give you a equals to v minus u over t, which is what I got here, a as v minus u over t. Now if we look at f1, then f1 will be m1 v1 minus u1 over t, and this should equal to negative f2, which is m2 v2 minus u2 over t. Okay, now cancelling these two t's, we should get m1 v1 minus m1 u1 equals to negative m2 v2 plus m2 u2, which basically means, rearranging the terms here, one would get m2 u2 plus m1 u1 equals to m2 v2 plus m1 v1. What does this mean? This means that the momentum m1 u1 of this object plus this momentum m2 u2 of this object, which actually is the total momentum before collision, should equal to m2 v2, which is the momentum of this object. It's an m2 here and m1 here, plus m1 v1, which is the momentum of this object after collision. Therefore, we have the total momentum before collision being equal to the total momentum after collision. And thus, the principle of conservation of momentum is mathematically proven.